Hello, everyone, and welcome to another episode of Learn with Jason. It's me, your friend Jason, and I am very excited today to be talking about what I'm considering to be a learning double whammy because first, we're going to learn something that feels very computer sciencey. So just learning stuff like that always makes me feel really smart. And then we're also going to have a super practical use case for it where it's going to fix something that most of us probably do every day on the web. So to teach us, let me bring to the stage our guest expert today, Charles Lowell. Charles, how you doing?
Hey, how's it going, Jason? I'm doing well.
I'm super excited to have you here. I'm really looking forward to this one because I just, I don't have a computer science background, right? And I never
Mhm.
went to school for this stuff. It's all self-taught. So just about everything I have is practical experience. And that means that a lot of things that sound computer sciencey feel really intimidating to me. And I feel like I'm like, oh, well, that's for somebody who went to college. And so to be honest, when I first got wind of what we're going to talk about today, I was pretty intimidated by the subject matter, right?
Mhm.
But with that little cliffhanger, before we talk about that, let's talk about you. So for folks who aren't familiar with you and your work, do you want to give us a bit of a background on yourself?
Yeah, so my name is Charles Lowell. I'm the founder and CTO of Frontside Software, which really now at this point encapsulates most of the arc of my career, which is pendulumed back and forth between the back end and the front end. And now kind of I'm doing a lot more back end work. But the idea that that got us started was, we were doing all this back end work, and this is, we're talking about the bad old days of 2005,
Mm,
and we realized that there were a lot of architectural patterns that were kind of just received knowledge, just accepted in the back end that weren't there in the front end, especially like web development. There just wasn't much architecture. There was just kind of Netscape Navigator and a JavaScript interpreter. And so
and a pocket
we
full of dreams.
that's right, in a pocket full of dreams. Right. For anyone who's done debugging by like clicking through alerts, this is before like console log in Internet Explorer. I was one of those kids. It's like, how many times can you click through 10,000 alert boxes?
Oh,
Um,
geez.
but so we tried to bring these architectural patterns over into uh, doing front end work. And we've bounced back, like I said, between the front end and the back end. But really, we're just all about trying to find the best, simplest way to do things. And I want to speak directly to what you were saying about, being intimidated with something that's computer sciencey, because I think one of the things that we're about to talk about has a really great answer, not just for like paradigmatically, but for that particular way of thinking about computation. If you want, I can just go right
Mm.
into it.
Yeah,
Because
so why don't we kick right into that then and use
Mhm,
that as an introduction for our topic today, which the computer science term for it is
mhm,
structured concurrency.
mhm.
So for folks who, like me, had never heard that term before we met you, do you want to give us kind of a high level of that?
Yes. So the idea is actually one of those absolutely profound ones that
Mm,
is you can use to make complex things simple. So if we the concept of structured concurrency actually dates back or is a derivative of the idea of structured programming. And we actually don't think about structured programming. It's a computer sciencey term, so to speak, but it is now the way that we do things. And so structured programming literally means if I have an if statement and I enter an if statement, I go in between to the curlies. Like there's no way I can go anywhere in the computer's like instruction set except out the other end of those curly brackets. If I enter a curly bracket, an opening, I'm going to flow control is going to come out the other side, right? It's just
got it.
that's how it works on while loops. That's how it works on a function definition. That's how it works on if statement. It's how it works on a switch statement. There's structure. You have like the structure of your program determines how the instructions are going to be executed in it. And what's funny is like it's so obvious to us now. right? It's because it's intuitive, but it wasn't
Sure.
always that way. It was so there was this guy who was actually a professor at the University of Texas called Edgar Dijkstra, and he was doing work in the 60s and 70s, and it was, your computer programs were just a big hairball of machine instructions, and there was no
Hmm.
structure to it. And so he was the guy
And
who
and
rolled
when
out
you
these
say
ideas.
when you say like it was a big hairball, this is when you start looking at like the go-to instructions, right?
Yes, the go-to.
Hmm.
Exactly. So go-to was kind of the way to do it. You would, even if you had a subroutine, you'd have your program would execute, and then you'd say, okay, I need to go to this subroutine, and then I can go over here and I can go over there. And so it became unmanageable. And everyone's kind of familiar with why go-to is a bad idea. Well, he was the first one to say that. He was the first one to say
Mm.
never. He's the guy who wrote the paper called Go-To Considered Harmful. Uh, and said we need to
Wait,
stop it. We need to never even do it.
is he the originator of the considered harmful
Yes.
format?
Yes, he is. Mhm.
I love it.
And what his key intuition is, and this is what's important when you think about things that are computer sciencey, is he said the most important thing, and this is the principle that allowed him to derive the whole idea of structured concurrency, is that the execution of our program has to follow the text of the program. Like if we see it,
Mm.
then we know what the program is going to do. And that seems, again, so obvious, right? But what he was saying is if I see a function call, if I call like console.log, console.log is going to take that string and it's going to go do something with it. But at the end of the day, I'm going to return back to the point where console.log was called. Program execution follows program text. It's such a simple idea. And so then he would say, okay, with this principle in mind, that if I can't see it in the program, it's not happening in the program execution. What does that imply? And so that implied the entire concept of structured programming. And so structured concurrency really is actually a simplification in the same manner of if I do not see an asynchronous process in the program text, then it is not running.
Mm. Okay. Okay. So let's talk a little bit about we've talked about structure. I think that makes sense.
Mm-hmm.
And I love this idea that like in retrospect, these choices are so obvious, but at the time
Mm-hmm.
they're groundbreaking. And I think it's I always think about it like wheels on a suitcase or a handle on a knife. Like
Mm-hmm.
after we saw it, we were like, how did we ever not do this? Right.
Right.
But up until that point, we had just accepted that you carried a suitcase. And you had
Mm-hmm.
to rent a cart
Right.
to carry your suitcase around if you needed wheels. So I think it's the same general thing where like we live with patterns because a lot of times we haven't had the opportunity to sit down and really question them.
Right.
So this is really exciting. So structure makes sense. Let's talk a little bit about concurrency. So for somebody who is sort of uninitiated to the term, what are we talking about when we talk about concurrency in? Let's stick to JavaScript today specifically.
Mm-hmm. Okay. So what I would say when you're talking about concurrency is that you are, and especially in the concept of JavaScript, is you basically have multiple functions scheduled to run at the same time. So in JavaScript, this would be like in your event loop, you've got a queue of things that are going to run, and you're doing multiple ones of them at the same time that can possibly touch the same data, and possibly be living in the same context. So, an example is, let's say I've got a web page or something, or let's say we can do two examples, one on the back end and one on the front end. I guess we can start on the front end, where I have a page that I need to load, and I want to fetch some API responses in order to render that page. I can do those in sequence. That would not be concurrent. Or I can do them at the same time. So I begin the process of getting one API response. Then I begin the process of getting the second one. Or sorry, I begin both of them at the same time. And
Gotcha.
then when they both come back, then I am able to continue. But the idea is that both of those things are happening concurrently.
And so this is the reason that this is interesting in JavaScript and a lot of other languages, but particularly in JavaScript, is that by default, JavaScript is single-threaded, right? So we are writing instructions, and those instructions have to be executed in sequence, like you said, as like a default. And when you get to something like you're talking about, where I need to make 2 API calls, and both of those are going to be, you know, I don't know, maybe 200 milliseconds, I don't necessarily want to do one and then wait and then do the next one, because that's when we talk about like network waterfalls and stuff. Those issues are there.
They're real.
But this is where I think things get really interesting, because we have options to do things asynchronously in JavaScript, where we go out of sequence and we introduce like a promise. And I know for me, this was a huge mental hurdle that I had to overcome, was when they first introduced promises in JavaScript. I was like, how do you even think, like, your program breaks, because you've got your program, and then you've got this thing shooting out to the side, and there's .then, and there's .catch, and there's .finally, and I was like, but that's not related to my program anymore. How do I get these things connected? And it started turning in to me to like this kind of tower of, or the pyramid of doom, you know, where everything was nested inside of another thing, was nested inside of another thing.
Right.
And so that, I think, is it just sort of laying some context for what I think we're going to talk about next. I think the impetus for things like async or async await in JavaScript were the challenge of the mental model of promises in a otherwise like linear programming flow. And async await lets us make it linear again. But only
if I could
visually.
just say, what's interesting is async await actually brings structured programming to asynchrony, right? So this idea.
Okay. So actually, that's a great,
like Dijkstra's original idea is the application of async programming using like async functions, because now if statements work as expected, try statements, while statements, all that stuff. So, you know, it's an attempt to bring structured programming to asynchrony, and so overall, I think it's, you know, it is definitely an improvement. It was a huge improvement from the status quo.
Absolutely. Okay, and so that's actually a really good example of a thing happening in I think a lot of our experience, where we went from promises to async await, and that's a really good example of exactly what you're talking about. It was hard, but we dealt with it because that was what we had. And then an option to make it more structured, make it visually flow. It's like, okay, that makes sense. Like, I'm going to do it that way.
Right.
But nothing's free.
Program execution follows program text.
Yeah. So there's no such thing as a free lunch. So what are the trade-offs when you introduce this type of programming into JavaScript?
What are you talking about?
Like with async await, and, you know, I think I guess what goes wrong with async await that would make something like structured concurrency necessary in the first place?
Okay. So the fundamental problem with async await is that there is no longer any way to say that I am no longer interested in the value that this asynchronous process is going to produce, or I'm no longer interested in the side effect that this thing is going to produce. So this is the fundamental problem, is that if I make an API request, and then let's say I'm in a single page application, I navigate away from that particular page or that particular route that's loading that data, I don't care about that data anymore. It's no longer part of the computation. But this thing is going to continue existing for some time, this request, right? You can think of it like this. If I've got a function and I have a variable, let's say I say const x equals 5, or, you know, const x equals new object, something like that. Once the function returns, I don't need x anymore. It's not part of the computation. It has passed out of scope. And so in JavaScript, we have this thing called the garbage collector, which which is really, really fantastic. And the garbage collector leans on the structure of the program. In other words, the garbage collector understands when something is passed out of scope. And once it has, then you don't have to worry about it as the program anymore. The runtime is going to clean it up for you. You know, there are better ways to do this. Rust uses ownership, but it's the same concept. You use the actual, you can analyze the structure of the program, see how it reads, and say, okay, we don't need this thing, and so we can reclaim it. So
got it.
Structured concurrency is the same concept, except applied to concurrent processes. And is to say, you know what? The value that's being produced by this asynchronous process is no longer needed. Therefore, if, you know, it's kind of like if a tree falls in the forest, but there's nobody there to hear it, you know, did it make a sound? You know, you want to kind of, to mix metaphors, you know, burn that tree out of existence if there's nobody here to hear it, right?
But this is interesting because it sort of answers that question with, if you fire off a bunch of asynchronous requests and somebody leaves the page, do those requests continue to exist? And the answer that you're giving me is yes, they do.
Yes.
So even if I'm on a page and I make a big asynchronous request to, say, the like analytics page of my dashboard, and it has to make a huge query, lots and lots of data, and I decide, you know what, I didn't actually mean to click on that, I meant to go to this other page, and I click away, I'm still going to have to download all of that data, because as far as the request is concerned, it still exists until it resolves. Right? So that's actually that's a big deal from, you know, and obviously in a contrived example, we can go, well, that's probably not that big of a deal. But like, even in the Learn with Jason site, for example, I have different requests that are multiple API requests that all come together, and they have to be done as one unit in order to succeed entirely. And if any of them fails, I don't necessarily want the other 6 to keep going. I want to immediately get an error and retry and not burn that extra memory or time.
Right.
So you're saying that by implementing structured concurrency, we have the control to be able to do that.
Yes, and I would say even more so that you have the control, like the default is that it does that. Because there are ways to mitigate these problems in JavaScript, and you know, I've worked with all of them. You know, abort controllers and abort signals are, you know, probably the biggest one. And so there are, you know, there are ways to cope, but it is always opt-in. And so what you're talking about is you make it so that, you know, you don't. It's not like you don't. What's the like the guardrails are there. It's kind of like the error, in the same way that the flow control for if statements and while statements, it's the air we breathe. We don't have to think about, like, saying, okay, now when I call this function, I need to pass a parameter to it that's going to tell me I need this function to return to this point. Or when I allocate a variable, I need to tell it, actually, I want you to tear yourself down when you're going. You're just going to have foot guns. So if we imagine a world without foot guns, then nobody gets their foot shot off. And so that's the and that's the problem. I actually see people writing in chat about abort signal. I'm actually in the middle of writing a blog post called "The Heartbreaking Inadequacy of Abort Controller," because man, it has broken my heart so many times. Which is why I ended up arriving where I was today.
But where you are today is a library called Affection. So let's talk a little bit about that, and then I think we probably want to jump over and start writing some code.
Okay. So Affection, in a nutshell, and in fact, this is actually the slogan of our project, is it's structured concurrency for JavaScript. And so our goal is to provide the simplest API possible that leverages your knowledge of JavaScript to be able to write JavaScript with structural concurrency guarantees. So we try to use every concept that is in JavaScript and have a mapping of that into Affection world. So for example, for wherever you would use a promise, you're going to use an operation in affection. Wherever you would use an async function, you're going to use a generator function. Wherever you would use a wait, you're going to call yield star. Wherever you want to have an async iterable, you're going to use a stream. Any place you're going to use a async iterator, it's going to be a subscription. And the APIs are almost exactly the same. And we've only added as much as needed to make them give you this ability to inhabit this world without foot guns.
Got it. Okay.
So you do have to there's a learning curve, but our goal is to make that activation energy very, very low, because there are other structured concurrency libraries out there, some really, really good ones, but there's a lot of API surrounding them. So, we're trying to be, our approach here is to be, something that you can sprinkle into your application today. It works really well you can call it from async code. You can call async code from it. And it's, really easy to embed.
Got it. Okay. All right. So I have a lot of additional questions, but I think it'll make more sense if we start looking at code. Okay. So let me take us over into this view here, and I'll do a quick shout out. Make sure if you want more on this, have questions. No, not that. Don't look at that. That's not what I meant to share. Here, this one. This is the one I meant to share. So there
That's my Twitter feed. You should all follow me.
Yes. So this is Charles' Twitter, and then this is a big old document about structured concurrency. This is some academic reading, light academic reading for anybody who is interested in such things.
Right.
And then
I would add that that's kind of like the blog post that was heard around the world when it comes to structured concurrency. So if you really want to get into it, I mean, this is the kind of thing where I read it and the scales fell off of my eyes. Same thing with the developers of Java. Same thing with the developers of Swift. Like this moved a lot of people technically from one world into another. So if you have the time, it does take like almost an hour to read, but for a computer science paper, it is very approachable. Very approachable.
Okay. I'm into it. I'm not going to lie to you, Charles. I'm not going to read this, but I hope somebody else does, because
All right.
But okay, so this is Affection. This is the library that you built, and this is going to be how we actually get into this. And then there are some good docs that I clicked in on the getting started. There's kind of like a mental model. We've got all the sort of good stuff here. And I'm going to stop there and ask you, if I want to get in and get started, what should I do first, as long as it's not reading an hour-long paper?
That's like the equivalent of eating your vegetables. Like, if you want to get into structure, you go read
what's the version that's deep
post.
fried and covered in cheese? That's what I want.
So I would say, I mean, we do have examples that are there in the documentation. I would honestly, I would just start writing a little script in Node that actually has state in it, like has like long running things that then you can exit out of very quickly. And I think our first example is going to show that pretty well of like how you might dive in, because I think it's pretty simple.
Okay.
First, I hope it's pretty simple.
Oh wait, I need to actually create this folder. We'll go structured concurrency affection, and then I'm going to get in here. We are going to get init and then create a new little node project, and then I'm going to open this up.
Okay.
All right, so I have the barest of bones here.
The barest of
just
bones here.
A plain old node project, and I'm going to create a new file called index.js.
Okay.
And then just to make sure that everything works the way that I expect it to, I'm going to save this, and then I'm going to run node index. And it says There we go. All right, we got Node running.
Okay.
We're on version 20, and I'm
Okay.
ready to write some. I'm ready to write some structured concurrency.
Okay. So tell you what, why don't you add affection to your package.json or to
And
the project?
is it just straight up affection?
Yep, it's just straight up
Look
affection.
at it right there.
Mhm.
Okay.
Yep, we should be getting version 3 or above. Yep.
Yeah, 303.
Okay. There we go. And then let's just create. I guess we can do it inside index. So you want to import main from affection.
Is that a named import
It's a named import. I just generally don't. The only time I use, and this is a little bit of a diversion, the only time I ever use default exports is for plugins, where I'm requiring something. Otherwise, I just find the name helps. So if a computer is going to do this import dynamically, then go ahead and use a default export. But for people, let's just use names. They're nice. And then so main is a entry point into like the affection world.
Okay.
There's another one that's low level, but main gives you a bunch of great stuff. Whether you're on Dino or Bun or Node or the browser, it serves as an entry point that gives you kind of automatic cancellation. So let's go ahead and make say await main, and then we're going to pass it a generator function, which is the course of our thing.
Do I remember how to do this?
It's function star. So that's a generator.
I did it.
You did it. You did it.
This is the first generator I'll ever have written, by the way. So let's
really?
let's go. I've seen them on the internet.
So it's, here's the thing about generators. Async, they are a superset of async functions. You can think of them that way. So they're both, I'm going to use a drop a computer science term here, but it's fine. They're both coroutines. Okay. But the difference is that a generator is a general coroutine, whereas an async function is a coroutine that is limited to the domain of composing promises. So you can, in terms of power, you can kind of think of it as like a generator is a class of things. So like if you think of an async function as like a car, you can, or a that gets you from point A to point B, a generator function is like a vehicle, including spaceships and airplanes and drones and boats. So really all it is everything you know about async functions can be applied to generators. It's just you need to actually zoom out like 10x, 100x. It's like it's an infinite gathering of power.
Got it.
So now what we're going to do is, first of all, we can just do our console.log here. All right, now that should work. Did it?
Oh no.
No, okay. Let's see what happened.
Cannot use import statement outside of, I gotta just make it a module.
Yeah, if you put your type module in there. Okay. All right, now I definitely saw that definitely worked. Okay, great.
There we go.
Okay, so now let's do something affection-y. So one thing that's different about structured concurrency is every function always returns, and this is something that's different from what you're used to. But if we put a suspend inside this main function, so say yield star, and then suspend is a function that you got from affection.
Yeah, I got it out of, yeah.
Mm-hmm. And now yield star, I usually put the star right against the yield, just because it really is. It's like a wait, okay. And now go ahead and run that again, but you'll see that your node program doesn't return.
Yes, we're stuck.
But hit Control C. So what happened there? And the answer is that you always will return from an affection function. which is a little bit weird. But if you put a try finally around that suspend,
Like inside the yield?
yeah, around around the yield, put a try
Got it.
finally. So put it, yeah.
This goes up here,
Mm-hmm.
and then this is the finally.
Yep, finally. And then you could console log like out of here or something like that. Right.
Okay.
Okay. So now when you run that and you hit Control C,
Oh.
it's actually running to completion. Okay. You can't do that with async await. And this is such a simple thing, but what it allows you to do is this suspend is actually a concurrent function in the sense that it's going to go off and it's going to do something, and suspend is kind of like the zero in affection, in that it goes and it always takes forever. But if what's happening is that there's a Control C handler inside main, which then exits main. And so then the suspend and this function passes out of scope, and so it's exited immediately. And so this actually means that, when it's time to go, it's going to start executing. And so it's always going to execute the teardown, always, without exception.
Okay.
So let's let that sink in, because this is
I think the thing that's always fascinating to me is when I see something like this, and this is like a stepping stone toward the bigger thing. But the fact that you can add a Control C handler into a Node program is already like an earth-shattering revelation for me. I did not know that was even possible. So we're going to learn a lot today, everybody. Buckle up.
All right. Well, fantastic. Okay.
So I get this in the abstract. We're basically putting everything inside of this main function. Great. And then that means that we can hold, waiting for things to happen. So we're like, this is the async await effectively. And then we also have a handler when everything is done, which is very cool. I'm already imagining ways that would help. I think Jacob even said, like, imagine if all your dev servers tore down like this. How many frameworks could benefit from having a Control C handler that just says, like, hey, here's what happened during your dev run or something. Like, really cool opportunities there. So let's maybe go a little more practical. I think you had an idea for like a really simple demo.
Yes. So actually, if you want to get started, I linked to a GitHub example repo in chat that maybe we could use as a starting base, because I think there's some primitives there that I think we can just kind of run through, and then we can actually do the coding of making it of leveraging the structure concurrency. So
was that this one here?
It's the one right below. Well, that's more like this is actually the teaser of kind of showing you how things might not be behaving the way that you think they are, how program execution might not actually be following program text. So in that example, this is more just like a brain teaser. Yeah.
Okay. So chat, here's a little challenge for y'all. Let me comment this part out, and then I'm going to put this up on the screen. And so looking at this code, how long will this program take to run? So we're running a promise race, and whatever the number is that gets passed in gets turned into seconds. So this one sleeps for 1 second, this one sleeps for 10, and what promise race does is returns with whatever the first one is that completes. So put your guess in the chat. How long does this program run if we run it? And while y'all do that, I'm going to get ready to run it. All right, we got a couple votes for 10, a vote for 1. Linda says 11. Let's try it. Did I not save? I didn't save. Hold on. Now we're going to run it for real. And 10 seconds. So
10
even
seconds.
though this completed after 1 second, we still had to wait for the slow one, even though this discards it.
Right. So
that's a really good,
the
like,
answer is
that's a
10
really good
seconds.
illustration of the problem.
Yeah, it's a really great illustration of the problem in one line of JavaScript. So the question is, why? Does anyone know why it took 10 seconds? And the answer, if I can, spoiler alert, or I guess just this is the reveal, is that the set timeout is actually a resource that is basically on, like, the node is holding on to and saying, I cannot exit until this timeout is going to be resolved. But there is no computation in the text that depends on that 10-second timeout. It's, we already have our answer. 1 second, 1 second won the race. And yet we have to sit around waiting for 9 more seconds in order to finally bail out. And so what's interesting about this is that it's a memory leak that's like, has a life of 10 seconds. So it's like, it's almost more pernicious than a normal memory leak, because these things where you're waiting 500 milliseconds too long, 5 seconds too long, they only reveal themselves at scale. So when you've got thousands of requests, or every request is just moving just a little bit over the threshold of acceptability, and so then all of a sudden things start really to have problems all at once. So
yeah,
it's
well, and I think that this illustrates, I think, one of the things that is really tricky when you start thinking in asynchronous patterns, like when you move things to work side by side, when you have data that maybe is going to run, but you don't actually need those, as you said, it only becomes like, it's really only noticeable at scale. But it's also, this is that death by 1,000 cuts thing that happens over time to a lot of big apps, is a little, like, you won't notice 200 milliseconds, but you'll notice if 200 milliseconds happens 15 times. And over a long period of time, as different people work on it, as more layers of complexity get added. Like, I remember I used to work at IBM, and one of the apps that I inherited, just over time, it sort of accumulated these geological layers of new code. And they were all blocking each other because they had set them to render, sort of like render and then load the next thing and start rendering it again. And I'm sure that when they did it, nobody was doing this on purpose, but it added up over time to this page taking 60 seconds to load. And each of the individual components is only a second or two. So it's like, whatever, it's only a second or two. But the net outcome is really rough for the user. And this I think is such a good example of, like, one of the teeny tiny ways that you wouldn't even notice that you're adding that sort of stuff to your code. Okay,
yeah, no,
so
absolutely.
You told me to start here.
Yeah, I would start here.
Okay.
And while you're cloning that, I would say what we're going to be doing, we've all used like NodeMon, or maybe we haven't, but or when you're doing you're using Vite, or the Create React app dev server. As you edit code, it will restart and reload. And so what we're going to be doing is, I created a base project that has a single little server. And what we're going to do is write a file watcher that restarts this server. And that may seem like a Herculean task, but with structured concurrency, it's actually really easy.
Okay.
So basically, here's what we've got that's something similar. So here's a main function. And I've written this use server, and then it suspends. So let's see if we can get that running. And what it's going to do is it's just going to print hello world over the browser. So yeah, run that start program.
Oh, I need to install my dependencies.
npm install, yeah.
Okay. So we're running.
So now if you start that, you should see.
There's our hello world.
There's our hello world. Fantastic. And so as we're, hacking on this thing, we could make it say hello planet or hello universe, but we're going to end up with a stale state. Where, if you say hello chat and then you go and you reload that page, it's still going to say hello world. which is not something that we want. So what we're going to do is we're going to implement a watch function, or watch capability, which will actually look at this source code, and then it will restart the server every single time it sees a display or sees a change. So if you go, I've actually started up the watch thing, but it's left kind of as an exercise for the reader. So if you look at that file right there, you can see it's going to have this use command. Now, if you want to browse into use command really quickly, just to kind of see it, it's really simple. It's what uses what's called an affection resource. And so this is going to create the child process, and you might recognize the kind of try, suspend, finally pattern here. But what it's doing here is, instead of suspending, it's actually going to be returning a value back to the computation that called it. So this is like we want to use a command. And so we're going to implement it saying use command. But what we're saying is once we're done with this command, we're exiting from it. And so we need to finally say proc.kill SIGINT. And so we're going to kill that command. And so what that means is that whenever we use a command, we can guarantee that it always gets killed when we don't need it anymore.
Okay.
And so it's simple, but again, profound. And so it's like saying, I've got this resource, it provides a child process, and finally kill the child process when the resource is killed, when I don't need the resource anymore.
Got it. Okay. So I'm going to repeat back what's happening here to make sure that I understand. So when I pass in this use command, I put in a command, and that command could be node, and then I have args, which could be, start or node index, or whatever it is. It then returns a resource, which is from affection.
Right.
And that resource uses, where does provide
resource basically gets passed. There's a resource function, there's a resource function which gets passed this provide operation. It's also worth looking online for that. You can see that a resource is just an operation that returns a child process. An operation is like a promise. Operation is affection parlance for promise.
Got it. And so what we're doing is we're spawning a child process that runs that command, and then we provide that to our application, presumably. And then if the application terminates this process or decides it doesn't need it anymore, this finally makes sure that it actually gets removed and isn't just left hanging in memory.
Right. Exactly.
Okay.
And so it's saying, like, you can't not do this. You can't not kill the process after you're done with it. Now, you might need that process for a really long time. You might need it for 10 minutes. You might need it for 10 seconds. But whenever it is no longer needed, it will receive the SIGINT signal. And so that means that you can freely use it. So now here's our watch script that doesn't actually work, but we're going to use this command, and then we're going to suspend. So if you look inside the package.json, the script, you can see we're passing the arguments there. So there you see the dev command. We're calling watch, and then we're invoking the tsx command with main.ts, which was
so here's our command. Here are the args.
Yep, there's the args.
And so that would mean then I need to get the command in args, or does it know to pick this up when you run it like this?
Right. So main actually passes you the args.
Nice. So I don't even have to do that work. Like I'm used to in like if you use yargs or something like that, you have to actually retrieve those out of the process. Right. So that's, you can still it normalizes it. Does some so whether you're using like if you're using Node or you're using Dino, it's gonna normalize those for you. Got it. Now this script, all it does is a straight delegation. So it's going to say use command, and then it immediately suspends. But this has the advantage that if we control C, it's going to actually SIGINT that process. Got it. So now if I stop this
Yep.
and I
And you
npm
run
run dev now,
yes.
so
It's
we're
going to do
watching.
the same thing.
We've got a different port, and
Right.
it's actually SIGINT when you get to the end here. Okay, good,
Exactly.
good.
Yep.
So
So
then
you can even use two commands. You can use that command twice, and they'll both like. So if you on line 5 put duplicate that line, for example, you would never do that. But
why not? We're here for the chaos,
right.
So we're running twice now.
Two, right? And when I can hit Control C, we don't need either of those commands. They both receive the SIGINT signal. And if you've ever done
what is it? LSOF
yeah,
wait, is that right?
5630. Yeah, I think so. 5633.
Like they're gone.
Yeah, they're gone. And if you've ever done any process programming in Node, it's hell. But this really wrangles it by putting strict structure around when that command is existing and when it's not. Once we exit that main function, the command goes away.
And this is pretty slick.
So let's start. We're going to make a watch function. So basically, every time that we receive a file system change, we want to restart this command. Now, the way that we're going to do this, let's just start, instead of watching, let's just restart it every 5 seconds or every 3 seconds.
Okay.
So what we're going to do is we're going to put a while loop around this. So just say while,
inside.
Yeah, say while true. Put around the whole thing, yeah, while true. And then we can move those commands up. And instead of suspending, let's say sleep 3000. Now there is one thing that we're going to have to do here. We're going to have to use call because we need to establish a scope around this while statement. So if you inside the while loop.
Inside the while loop,
yeah.
Okay.
You want to say call, and then that takes a function star. It takes a generator.
Oh, got it.
I like to call them an operation function. Yep, and then move those two things up into there.
Oh, and I need to actually do one of those.
Yep.
Okay. So
okay, now let's run. Yes. Yep.
So effectively what we're doing is we are just continuously calling the loop to start the command. And actually, how does this cancel the command? Because wouldn't this just start a new one because it would keep getting called?
Well, that's what's interesting is once we finish our sleep, we exit the call. The command is no longer needed, and it just goes away.
Oh, so what you're saying is this call creates a scope, so that scope is continuously opened and then destroyed. So I get it. Okay, I'm with you. All right.
So this is actually something to note. Is it like a sidebar? Is when you're using structure concurrency, you hardly ever explicitly say halt or cancel or tear down or shut down or this or that. It just happens when things pass out of scope. In the same way that you don't deallocate variables, you let the garbage collector take care of it.
I think I broke something because we're not getting our port.
Let's see. Okay. Oh, right. You need to yield. So that you can kind of think that call constructs the promise, but you need to yield star. It's like in the same way that you need to await. So this is also a key difference in affection is that operations are stateless. They don't do anything. You actually have to await them or yield to them.
Okay, so here they go, continuously doing their thing.
Right, and if you click on some of those old ones, you should see that they're not, like those old links are like, don't exist anymore.
Got it. So we should probably set an actual port here so that we get that update. So our use server, and then the port was, let's go with one that I'm pretty sure is free.
Okay.
And now it should always go to these. There we go. Okay. Yeah. So now if I come back out here and I go to 4444, we get that. And if I come in here and I say hello updates, it won't change anything yet, but when I refresh, did I do this wrong?
What?
Oh, there it is. There it is.
That's right. So we're only doing it every 3 seconds. So you might have
so I was early, yeah.
Right. So what we're going to do now is we'll replace this sleep with something that's a little bit smarter.
Okay, so let's go to our watch again. And so this then needs to be something that says if, let's see, what do we get? The file itself, whenever it gets changed, is going to have like a modified date, right? And so we should be able to just see if it's been modified.
Well, so what we can do is we actually want to we want to be proactively notified of when this file changes. So Node actually has a file system watcher. And I'll tell you what, let me go ahead and link to that. I probably should have. So what we're going to do is we're going to use this guy right here, and I'll post this. I guess I can post it in chat here. Here you go. Oop. So we're going to use this, and what we're going to do is we'll create in the same way that you would use an async iterable here. And tell you what, let's just go ahead and copy that file or copy that code from the Node example and just comment it out. But you can use that too. Yeah.
Just like that, right?
Just like that.
Okay.
And then what we're going to want to do is create a subscription. So what we're going to want to do is the way that you would consume this normally in Node is with an async iterable. And if we look back at our Rosetta Stone, we have the concept of an async iterable. It's called like a stream, and the async iterator is a subscription. So we want to convert this watch thing into an async iterable. We're going to take the async iterable and convert it into a stream, and then take that stream and convert it into a subscription.
Okay.
So we can use that code. I would just copy that const watcher equals watch line there.
Okay.
Okay, and let's I guess we could just do it right in here. Yeah. So if we after line 7, we create our watcher.
After line, so it's 7. Inside the call. Okay, I got you.
Inside the call, yeah. Yep. Okay. Now that thing. Right. We need to create. So here's this actually is perfect. So if you before line 7, you say const signal equals yield star use abort signal from affection.
Equals yield star.
And then it's use abort signal. Okay. Now you'll notice that this is different than the way you would use this normally in JavaScript. We're only working with the signal. We're not working with the controller. So we've already cut the API in half because we don't need to care about we don't need to care about calling the abort signal. When this scope is exited, that abort signal will fire. Basically, so when you use this abort signal resource, what it's saying is, and if you look at it, that's the same thing where it's like create a controller, yield the abort or provide the abort signal, and then finally controller.abort. And so, but what it lets you do is now I've got a signal that is tied to a scope. So when the scope dies, the signal dies.
Right. Okay.
Right.
Okay. Okay. So this is making more sense to me, and I just connected a dot because we're not going to be like randomly running this anymore. We're waiting until something has changed, at which point we would need to recreate the watcher, which is why we're creating it inside the scope. I'm with you. I'm back. We're on the same page again.
Okay. Awesome. Now, is that watcher there? What type of is that a async iterable or an async iterator.
It is an async iterable.
It's an iterable. Okay. So what we want to do is we want the equivalent, if we look at the Rosetta Stone over there for an async iterable, is a stream. Okay. So what we want to do is we want to say, you can just say const watcher, and then I would just wrap a call to stream. Let's just create it inline. So you can say const watcher equals, and then there's a function called stream, lowercase stream. And then that should be an affection, yeah. And then, yep, just do that. And now watcher should be a stream.
It is.
Yep. Okay, and so now what we can do is a stream is something that you get, just in the way that you use an async iterable to get an async iterator, you use a stream to get a subscription. So if we just, we probably want to do this before we use the command. We want to say const subscription equals yield watcher.
I'm realizing the hardest part about generators is spelling yield.
Yeah. Okay. So now you should have a subscription there. You can it's not a function.
Just like that?
Just like that. So now subscription should be a subscription.
And it is.
Okay. And then we can say yield subscription.next. Just like we would an async iterator. Now, I think we're going to want to change on line 9. Let's just change that to the circ directory right there. So let's just change that to the string. Yeah, because that's underscore file name is that's only going to respond to changes to, yeah, there you go. So now, just to review here, what we did is we created a watcher, used the watcher to create a stream. We created a board signal, which is bound to the current scope, which is going to kill the watcher when it's not needed anymore. And then instead of using a sleep to resume our function, we are just waiting for the next change event. And then our call is going to exit, and then our command is going to get torn down.
So,
what
we should see here then is we're calling the watch function, and we're passing in TSX, the name of the file, and then we're saying pay attention to the source directory, and whenever the source directory changes, because that's what this node thing, node watcher does, it will. We have an async iterable that's converted to a stream. The stream goes into a subscription, and then we get a .next, and the .next only fires when something happens inside of that stream. So, so effectively, it will ignore everything except changes to the source directory. Great. We're like 5 layers deep into new stuff for me, and this is very exciting. So what should happen in practice here then is that what we'll see when we start using this is right now, if you notice, we're running and it hasn't re-triggered again. So we haven't done anything that would trigger the subscription. When I update main, when I hit save here, we should see this generate a new log. And it did. And if I come back out here, it's updated. That's really cool that we were able to build that in so few lines of code.
Yeah, that's, I mean, those extra lines of code that you deal with cancellation and halt and dealing with all that stuff, it just adds up. The noise actually is important. So just shaving off 10%, 20%, really it adds up. And because what it's about is the composability. Because when I use that command resource on line 12, what's interesting there is that then I don't have to worry about how it's going to be torn down. So I don't have to include, none of that teardown logic has to leak into this. It's not my concern.
Yeah. I can definitely see. I can see how this has compounding benefits
Yeah.
as you sort of continue to build, because one of the things that's hardest for me, and I think hardest for teams in general, is that as you start to build things, the implementation details start to sort of leak outside of where they are actually contained. And so, as you said, if you've got a cool, thing that's async, but in order to use it, you have to wrap it with a try catch. Now you don't just get to tell somebody use my thing. You have to say, well, use my thing, but you have to use it like this, or else you're going to have problems. And you have to understand what some of those underlying problems are, or you'll say, well, I don't really care about that. I'm just going to do it this way. And it sort of like, again, it just sort of starts that slow ballooning of things are hard to work with, hard to manage. Nobody really remembers why it's written that way, so we just append to the bottom of the file instead of actually editing the code. Those sorts of things that are really, really challenging. If you know that, this command that's being run, when you look in use command, this is all self-contained, so whatever's happening in here is fine because it's going to kill itself once it gets out of scope. And we know that if we're in here, anything that's done in here is a contained scope. Suddenly all that cleanup, like there's still, obviously you still have to teach the team how to do this, which getting a whole team to switch over to generators, it's going to be a challenge. Like people are intimidated by these, and rightly so. There's a lot of mental, like these are new concepts, and we're getting away from I think generators are one of the more challenging concepts because they get away from like, you can sort of picture what a loop looks like with a physical analog. It is very difficult to picture a generator with any kind of physical analog because as far as I know, there isn't one. Like
true. Although, what's the difference between this and async await? So if you were to replace all those yield stars with awaits, and you were to replace function star with async, what would be the difference in terms of the readability? I think what the generators let you do is precisely the thing we were talking about at the top of the conversation of you're taking callbacks and you're able to stitch them together in a linear function. Because at the end of the day, we do have, starting on line 6, we're using a while loop. The only difference is it's an infinite loop, and which is also kind of crazy. But it's still, what you're saying is I have a loop and these things happen in sequence in this loop. And inside that call, those things have to happen in sequence, even though they're totally happening concurrently.
Yeah. I like 100%. Question from the
chat.
It
is so here's what I would say with the generators is, one, there really is no difference between learning generators and learning async await. Everyone forgot how hard it was for them to make that leap, but once you make the leap, it's like, oh, it's the wheels on the suitcase. It's the knife with the handle. It's obviously we want to express things in sequence. Same thing when you go to generators, it's just a continuation down that path. Second thing is the way you get the team to adopt it is you give them a taste of something like this, where you're like, I couldn't even imagine how to do that. I would have reached for some, I would have done npm install hairball to get some off the shelf solution that's 1,000 lines of who knows what versus, oh my goodness, we did this in 15 lines of JavaScript. Once people give it a taste, the taste creates the appetite all itself.
Sure. Yeah, no, I think that's and that's a good point. Like I think this and some other stuff that feels intimidating to start. Like I think state machines are another one where once you use a state machine, you go, oh yeah, I should be using these all the time. But the initial setup is a little challenging because it's a new way of thinking. It's very different from the more kind of imperative, like I see all of this in a line, and if I didn't write it, it's not happening, right? And so it's kind of nice to get that explicitness. You get the explicitness here, you get the explicitness in something like a state machine, and if we can push through that initial learning curve, then there's a lot of benefit to be had in working this way. So Linda had a question that I think is a good one. If we're creating and tearing down all of these scopes, is there a way that you can like, is there a good way to debug? Like, how many scopes have I created? Is there a way to see like what scopes aren't closing down, or did I miss a step somewhere?
So that is a really fantastic question. The answer is not currently in V3 of Affection. There was a way to do it in V2. We would like to bring that back.
Okay.
So we step back to V2. If we step back to V2 Affection, and really just in fact Affection in general, the key insight is that just like you have a stack frame or a stack that is consistent of a bunch of stack frames, Affection maintains a tree of stack frames effectively. So it's taking that linear array, and instead of at each child, you can have a tree. And those children in the tree represent the concurrent processes. Yes, internally inside Affection, there is an explicit data structure that represents the tree of all the scopes. Now, in V2, we had developed an inspector that was basically a React app that lets you connect to any Affection process and visualize that tree. In V3, we have plans to. We just haven't done it. I think we released it in December, and this being open source, it's just kind of the priorities that of the day carry where you will. But absolutely, yes, we want to develop the inspector for V3. We have a lot of ideas for how it could go. We want to get it right. And so we've had a couple of different spikes. Some of the people in the community have had a few stabs at it. We haven't settled on one thing, one particular approach, but it is very much a priority because it really makes a huge difference. With promises, it's just a promise is just a glop of code that has a bunch of people who've registered callbacks. Whereas, a Affection operation is always part of a tree. And so you know exactly where it stands. And that's huge information.
Yeah. Yeah. I can see why, why you were so excited about this. And I know that Jacob has told me a lot about this and is also very excited about it. I can see how this sort of, can create a little bit of like, oh wait, I can write good software. I think a lot of my, at least my experience with software is usually what I'm trying to do is solve a problem. And I know that I'm creating problems as I go, and I just trust myself to come back and fix them. There are very few places where I'm writing software where I'm like, I know all of these edge cases. I know I've got this covered 100%. We're going to be fine. Having something like this kind of makes me feel more confident that I can, for the cases that this is for, feel pretty confident that I covered all my bases. And that's nice.
Yeah. Yeah, no, it is, just to that end, we haven't talked about this explicitly, because what's interesting is I'm actually kind of surprised myself at how few hiccups we've had so far. So I think that's kind of a small validation right there. The other thing I would add, though, is that because of that, we didn't get to see one of the key benefits is that Affection and structured concurrency in general is really good at propagating errors. If you've ever seen like that unhandled promise exception or like whatever. Okay.
Like we got a few minutes. Let's break it. How do I break this?
Okay, so what you can do is let's spawn an asynchronous process inside here that, like, if you don't make a change within 5 seconds, it's going to blow up. So like, let's say do like yield star and then spawn. So this is the way that you create an asynchronous process in Affection. So now the spawn is like call, where you pass it a generator function.
Do I want spawn from child process
you want spawn from Affection.
Got it. Okay. And sorry, now what do I do?
Now you want to, it's like call, except call is sequential and this is parallel. So you want to, it's a generator function.
Generator, right. And there's no shorthand for generator functions, is there?
There isn't. I think there should be. There's a TC39 proposal for it. I think what's really, this is again another separate thing, but once you use generators, you don't need async intervals. You don't need, there is a, what's the word I'm looking for? A chasm, a schism in the JavaScript community or in the JavaScript runtime between synchronous and asynchronous. But the thing about generators, because they're unconstrained by the semantics of promise. In other words, remember, who is it? It's Yodabyte said, I've never thought about comparing async await with generators. And that really is apt because generators are a superset of async await. Async await are like generators, but the only thing they can work with is process. A generator is just like an async function, except instead of awaiting a promise, you can yield to anything. You can yield to anything. So the domain of values that you can work with is unlimited. All of that is to say that operations, unlike promises, can resolve synchronously in the same tick of the run loop or asynchronously. So there is no schism to hold in your mind of, am I working with async code? Am I working with sync code? Is this an iterable or an async iterable? Is this a async dispose resource? Like for those living on the cutting edge and implicit resource management, is this an async resource or a sync resource? All that just kind of goes away. Nice. So working with generators really is there's a lot of practical advantages too. Okay, so anyway, point being, spawn is the concurrent equivalent of call. So what we're going to do is let's sleep for 3 seconds. We want to, and again we have to yield, which is the equivalent of wait.
Okay.
And then let's just throw a new error. And maybe we'll make it, something like that.
Okay.
Yep.
So I have.
Now, what's interesting?
So theoretically, this should fail any second now.
It should. No, because not the watcher function is not.
Oh right, that's not watched.
It's not being watched itself.
Who watches the watcher?
That's right.
Okay. So 3 seconds have passed. Our error died. Here it is.
Yep. And the whole thing. So what's interesting here is that errors in affection and in structure concurrency are always catastrophic. They will maximally crash everything, which is, you think like, is that really what I want? And the answer is yes. You want that error to be in your face so that you either deal with it at a specific point to say, I implicitly catch this error, or I'm like, you know what? It crashes your entire process. So it forces you to deal with errors, which is actually what you want in the long run, because it's in affection, it's impossible for an error to go uncaught. Whereas like you can open up your inspector console and see, oh, I've got all these unhandled promises, or this thing failed or that thing failed.
Very cool. Okay. Is there a specific way, like if I want to handle an error, do I do something special, or is it just kind of a try catch?
You can just use it. So put a try catch around that call. Not there. I would put it around line 7.
Around line 7.
Yep.
Oh, just a whole thing.
Yeah. Just put it right there. Yeah, the whole thing. Now, what's interesting is when that error happens, it's
here to here. Okay.
Now before you do that, let me demonstrate one other thing, because I think this is actually important to before, if you can unwind that just briefly. What's interesting here is that, let's say you touch that file before 3 seconds and you restart, it's actually not going to crash.
Oh, right. Yeah, because if let's see, I will open up my main and then I'll npm run dev and I'll just save it.
Right.
And every time I do that, I reset the timer.
Yes. But I didn't have to cancel the timer. I didn't have to do like whatever.
It's
you
gone.
stop for 3 seconds, it blows up.
Okay. All right. That's cool. And we're not manually managing any of that.
Right. It's just that spawn, that kind of time bomb that you've put in there, so to speak, is bound to that scope. So when that scope goes away, so does the time bomb.
I like it.
Yeah. So you can catch it. You can catch it by putting a try catch around that call, and then you can explicitly deal with it, and it's caught just like it would normally be in JavaScript. The only difference is that's an asynchronous. What's interesting there is that you have a concurrent process that you're not actually awaiting. You're not actually awaiting that, and that's not the behavior. So if you in JavaScript, you would get an unhandled promise exception, or you get that logged out to the console.
And so in this case, what we should see then is just a log. And I did.
You got a log,
I did the
but
whole.
It probably. Yeah, you
I do just the message.
Message.
Let's try that again. Oh, actually, it didn't even crash last time. That's cool.
Yeah, it won't crash.
Look at that. It fails and it just reboots itself. It's like, hey, let's try again.
Right.
Cool.
And
so this is actually huge, because this means you can make resilient, like you can without doing anything wild here, like a try catch, I think is pretty standard.
Right.
We have a resilient process. Now, obviously, this isn't ideal where it just continually dies, but like we have the opportunity to catch an error and like change something and try again, so that we don't get the error, or like have a maximum number of retries before we. Yeah, this is very cool. This is very
before you exit. But again, what's nice is you're able to just use the simple primitives of JavaScript, if statements, while loops, functions, to express your program, including all of the error recovery.
Really.
So yeah,
really cool
and in
stuff.
fact, there's in this you start to get into the space of like Erlang supervisors, where you can have a single process that's managing like 10 different servers, and if one of them crashes, I want to restart them all. Stuff like that. But I want to make sure that they finish handling any requests that they were doing, and so this is like the building blocks that all of these incredibly complex behaviors can be built on. And so, but by allowing you to reason at this higher level, it just makes what's possible for you that much larger.
Very, very cool. Yeah, this is awesome. Okay, so we're coming up on we're just about out of time. So I imagine we probably don't. We don't have time to actually build anything else. So
okay,
let's instead, for anybody who wants to take this further, what should they do next? Let me just start by throwing another link into the Affection library. Where else should someone go?
Where should we go? Okay, so I would say, certainly read the piece on thinking in affection. Because that will then kind of give you the tools. Those two pieces that are really up at the top, the thinking and affection and the async Rosetta Stone, those are the most important concepts to have, so that you can then apply that to any problem that you like. How do I solve this in an affectiony way? Because I know for me, I definitely came from this explicitly canceling, explicitly killing, this imperative mode of having to do everything to like tear stuff down or worry about, managing asynchronous processes. And so, it was actually, I'd been working with affection for a long time before I realized, oh, you know what? The best way to get rid of a resource is just to make sure that this returned from a scope that it was living in. Whereas, and we didn't even cover this, when you spawn a task in affection, it does have a method called halt, so that you can use to explicitly halt something. But if you'll notice in all of these examples, we didn't use halt once. We just leaned on the structure of our program. What was in scope? What was between the curlies at any given time? That, it's alive if it's in there, it's dead if it's not.
Got it.
And so those guides, we spent a lot of time on like, okay, what are the really core practical concepts, and then how do I map them onto JavaScript? So I would start there, and then the next thing is I would jump into the Discord channel. We have people who've been using it in React. We've had people who've been using it in Node, people using it in Dino, people using it for a bunch of different people using it for testing, where setup and teardown is very critical to testing. So there's a lot of different uses. Right now, we're very much in the stage of, we have the library. The library is very solid, and it's very minimal. It's like having JavaScript yourself, or like it's like having JavaScript itself. But there is not, the ecosystem is very nascent. So there's like 3 different ways to use it in React. But there's already some frameworks for doing state management and stuff in React. So I can give a shout out to like StarFX, which is basically a very similar to Redux, except using it's StarFX. Yep, all of those are. That first one is it. Sure. Yeah, right there.
Okay, got it.
Yep. So whatever your use case is, I guarantee that you will be able to use structured concurrency, because it is a general advance in programming. Like, it is a new state of the art. And I've mentioned Java and Swift a couple of times, as kind of being on the advanced guard of doing this. Like, these are now baked into this concept is baked into Java. This concept is baked into Swift. I almost feel like JavaScript was a victim of its own success and its own forward sight, in the sense that async await really landed in like 2013, 2014 timeframe, and this stuff became generally known in like 2018. And so by being so ahead of the curve, I feel like we actually lost out. But the point is this is here, this is ready, and this will absolutely make your programs better. So jump in, whatever your product is. There's a lot of people working on it, and in a bunch of different contexts, and you will connect with someone who is operating in the same context.
Very, very cool. All right. So, Charles, this was a lot of fun. I feel like I have a lot of new information like jammed into my brain right now, and I need to go write some code to try to get any of it to stick. Any parting words for everyone before I tear us down here?
Yes, I would absolutely say that the key to structured concurrency is bringing the code in line with your intuition. When Dijkstra said that the program execution needs to follow program text, what he's really telling you there is that if you're confused, if what you're seeing is not matching with your intuition, then there might be something wrong with the actual programming language runtime, not with your head. And so what we need to do is really ask ourselves always, 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 what does my intuition tell me? Is this program executing under what I can intuit about it by reading the program text? And structured programming, and by extension, structured concurrency, is really trying to bring program execution in line with your intuition. So you don't need a college degree or 2 decades of studying computer science to really lean on your own intuition. And that's what I love so much about Affection and structured concurrency in general, is it lets me lean on my intuition.
I love that. I'm gonna be thinking about that as I continue writing code. That's a good one. All right. Well, Charles, I'm going to send you backstage, and I'm going to get everybody off to their next adventure here. This show, like every show, has been live captioned. We've had Ashley here from White Coat Captioning doing all of that for us. Thank you so much, Ashley, for being here. And that has been provided through the support of our sponsors, NX and Netlify, who are kicking in to make this show more accessible to more people. Thank you very much to both of them. Go click on their websites and tell them I sent you. Make sure you are checking out the schedule while you're checking out things on the internet, because there is a lot of fun stuff coming up. Next week, we are going to learn about Valtown, which is serverless and a whole bunch of fun stuff that I only marginally understand. I'm very excited to learn about. And then the week after that, I'm going to be in London. So if you are in London, I'm going to CityJS. There won't be a show that week, so make sure, if you have the chance, either tune into CityJS or say hi. All right, y'all. This has been a ton of fun. I am very excited to go and learn, or go and play with all these new things that we've learned. We will see you all next time.